of the learning program Digitalized Manufacturing for Industry 4.0. I hope you can understand me well and also already see my today's presentation. So I switched my camera off because the focus should be on the presentation and not on me. And before we start, I would like to show welcome words from my colleague, Mr. Sebastian Blau. And it's also already a test for the audio and the video function.
Chumretsur, and welcome to this online course, Digitalized Manufacturing for Industry 4.0. My name is Sebastian Plau, and in DMG Mori, I am responsible for the cooperation with educational institutions worldwide. I'm very, very happy that finally, after a very long preparation time, we can start with this course. We have all been looking forward to this day, and I hope you will enjoy it. This course is not just an introduction to CNC technology, to automation systems, 3D metal printing, and digitization. It is It is supposed to be the starting point for an industrial revolution in Cambodia. A revolution that supposedly, hopefully, will propel the Cambodian industry into a new era. The goal of this course is to give you an idea of the importance of the metal cutting industry and the influence it has on many, many aspects in your lives. No matter whether you are holding your toothbrush in the morning, your cell phone, or you check the time on your watch, you recover from an accident thanks to the screw in your bone, drink from the water bottle in front of you, or you watch the spaceship fly to the moon. All of these objects require CNC technology to be manufactured. It's everywhere around you. Also in Cambodia, there's a huge potential also for you. The market size for metal cutting, for the metal cutting industry, is estimated to be worth around 80 billion US dollar per year. With this program, we want to encourage you to see the chances for you and for the development of Cambodia and grab those chances. Under the guidance and leadership of Dr. Kalyan, this program was developed. Thank you very much. And I would also like to thank Dr. Pekday for his strong commitment and efforts and his knowledge to bring this course on the road and have us start today. We, as DMG Mori, are very proud to be part of this movement and to contribute, small but important. DMG Mori is by far the biggest player in the field of metal cutting, with more than 5 billion US dollar turnover per year, more than 7,000 employees, and more than 150 subsidiaries, including 14 factories worldwide. Within DMG Mori, the DMG Mori Academy not only takes care of the training of our industrial customers and of our own service technicians and application engineers, but also taking care of cooperation with universities like RUPP and schools worldwide. Now it's up to you to take those chances. You are a very diverse group. We have participants from various faculties. We have even some participants whom I warmly welcome from companies. Some of you have already been exposed to some CNC technology. So some of the content might be not new to you, but it might be new to others. Please, I ask you now, turn into vampires and suck the knowledge out of the lecturers. Ask them whatever questions you have. Use this opportunity. Good luck and good success with this course. Thank you very much.
All right, ladies and gentlemen, I hope the quality was okay. Did you join the video?
Yes.
All right.
Yes. Yes.
All right.
Yes. Yes.
Thank you for your feedback. Though I would like to also introduce myself. My name is Jürgen Kemmler. I'm 53 years old, and since my apprenticeship as a lathe operator more than 35 years ago, I have been working in mechanical engineering and especially in the field of education and training. After my apprenticeship, I worked as a toolmaker for 12 years, graduated as an industrial master of metal engineering, and then worked as a CNC and CAD/CAM instructor for 7 years for a vocational public training center. I have been employed at the DMG Mori Academy in 2005, first as a trainer and recently in the training management. I'm not only a lecturer, I'm also a workshop man. I like to work in the workshop with machines, conventional machines or CNC machines, doesn't matter. It's a pleasure for me to teach you. I hope you can follow my instructions, my presentation, and wish you a good success. I also want to introduce later on DMG Mori as contractual partner of your university and of the entire program. Of course, questions are encouraged, preferably at the end of the session. If I don't understand the question, please repeat it or use the chat function. And please don't hesitate to ask. So, some words to DMG Mori. DMG Mori is a global manufacturer of machine tools with a history dating back to 1870. The company is a result of a fusion between German company DMG and Japanese company Mori Seiki. Worldwide, over 10,000 customers in 79 countries are served from a total of 154 sales and service locations. DMG Mori manufactures its product at 14 production plants and has around 12,000 employees. This slide shows you the 14 production sites in the USA, Germany, Italy, Poland, Russia, China, and Japan. Today's session marks the start of the program Digitalized Manufacturing for Industry 4.0. First of all, the most important branches of industry are presented with their specific features and exemplar components. The second session covers the fundamentals of material, science, and mechanics. The third session gives an overview of modern machining processes. The fourth and fifth sessions deal with the construction of modern CNC machines and the most important manufacturing processes of turning and milling. Sessions 6 to 12 deal intensively with the digitalization of production processes and advanced technologies, such as ultrasonics, laser technology, and additive manufacturing. The last three sessions deal with the topics Industry 4.0, automation, lead to CNC control technology, and to CNC programming, including basics of production planning and preventive maintenance. At the end of the program, there will be a final exam with multiple choice questions on all 15 sessions. The date for this test is the 16th September 2021. DMG Mori product portfolio includes the 5 manufacturing technologies: turning, milling, ultrasonic, laser tech, and additive manufacturing. In addition, automation, integrated digitization, training, and service. Technology excellence describes the close collaboration with customers to develop common solutions for specific applications and special processes. I have a question to you as audience. Which different industries do you know in the context of the production of workpieces? Maybe you can use the chat function. Okay. And next, I will show you the most important industries in the mechanical engineering field. Most computer-controlled machines tools are used in the following industries: aerospace, automotive, for example, motor cars, commercial vehicles, trucks or lorries, building, agricultural, military, and rail vehicles. Direct manufacturers and suppliers are considered here. Die and mold means many objects that used every day are made of plastic and are manufactured by injection molding. For this purpose, appropriate negative molds made of steel are required. Then we have the medical field and the field of power engineering and general mechanical engineering. Of course, there are other sectors which are more or less directly and indirectly linked to the main industries mentioned above. For example, metal production, metalworking, precision engineering, optical industry, electrical industry, shipbuilding, watch manufacturer, etc. We talk about 42 branches in total in this field. I would like to start with the aerospace industry. As shown in this slide, with already some examples. Later on, I show you more examples. Average growth rates of more than 7% makes aerospace one of the global growth branches. Unfortunately, the growth is currently interrupted due to the corona pandemic. Nevertheless, it should be noted that nowhere are the demands on technology and production higher than in the aerospace industry, because most of the workpieces or components have high quality specifications and highly security relevance. Certifications such as ISO 9001 form the basis for process-oriented quality assurance. Special requirements are placed on materials used in the aerospace industry. Following properties are often required. Materials in the aerospace should be strength or rigidity. Then the fracture toughness is important, fatigue behavior, and of course, corrosion resistance. The cutting of materials in the aerospace industry is a very special job. Challenges such as lightweight and hybrid materials, high temperature steel, superalloys, titanium, or other hard-to-cut materials are accompanied by the need to provide the best quality and surface precision as well as size accuracy in extremely narrow tolerance ranges. First, to further introduce this industry, I would like to show a short video and then some sample workpieces.
Over 20 years of technology experience for all applications and materials in the aerospace industry, from customer consulting to turnkey solutions. 20 years of milling turning technology, best class for castings and rotatives. There are certain industries that demand far more from their machine tool manufacturers than others, and clients that consider the highest performance to be just good enough. So that Answers produce innovative solutions. Through an early integration into the product development of customers, DMG Mori develops optimal production solutions for the aerospace sector. The shared goal, forging new paths together in order to advance future innovation. New materials and the development of economical machining methods that guarantee maximum efficiency with the highest quality and precision. And to find new ways of working together to expand the horizons of all partners. What drives us is simply the constant pursuit of higher goals for maximum reliability, efficiency, and sustainable limitless mobility. Welcome on board. DMG Mori Aerospace Excellence, the green button process.
All right. Okay, on this side, you see 85% of all aerospace components are made in mechanical engineering. Typical workpieces you can see already here, like nozzle for a rocket engine, or camera housing, or integral component, pylon ribs, frame components, chassis cylinder, fan blisk, inside housings, fan disc, or turbine blades. Many parts are for the landing gear components, like the landing gear or a torque link. Also, we have parts in highly stressed components, in wing components, auxiliary components, and aluminium structural components, like shown here. A wing rib, for example, a flap track, pylon rib, or engine mounts. And also we have a lot of components in the engine. Engine blade, for example, combustor casing, high pressure compressor blisk, several rings, fan blisk, we had already, fan disc, shafts, inlet guide, vanes, compressor casings, low pressure turbine disc, or low pressure turbine casings. This picture is from an engine made from Rolls-Royce in this case. So another video shows you a workpiece machining, in this case an aluminium structural component on a milling machine. All right. At next, I would like to take a closer look at the automotive industry. Rising sales figures in both the traditional North American and European markets, as well as a high growth China, characterize the automotive sector. Manufacturers in this branch and their suppliers are confronted with the challenge of how to come up with a fast and economically production solution that will give them edge in the fiercely competitive markets. Low unit costs, automated processes, and a high level of flexibility are the key factors in this industry. An automobile consists of up to 10,000 individual parts. Many of them are manufactured by machine tools, particularly in combustion engines, transmissions and drives, chassis, braking systems, and many components are installed which are manufactured by cutting. Similar to the aerospace industry, many components are subject to high safety standards. Components must have high accuracy, be wear resistant, and be easily and economically produced in large quantities. Therefore, especially in this industry, machine manufacturers and automobile manufacturers work together on optimized production processes, special machines, and automation solutions, with the goal of producing as economically as possible. To further introduce the automotive industry, I would like to show another video and then some sample workpieces.
Those who build cars require standard production equipment that sets standards worldwide. Those who build cars will only celebrate future success through strong sustainability. Those who build cars only reach the top of the industry through impressive precision. Those who build cars regularly achieve high speeds by being driven by intelligent innovation. Those who build cars can only influence the daily race for market share through maximum efficiency. Those who build cars only achieve a decisive victory through highest precision. Those who build cars need our machine tools. DMG Mori, Automotive Competence.
Oh, I'm too quick. Sorry, I have to jump back. Oh, this slide. Okay, here you can see 100% of the metallic parts and the complete range of plastic molds are made in the mechanical engineering field. For example, you see an automotive here, some connectors made by turning machines, gearbox housings, yeah, made on milling machines, camshafts, cylinder heads, cylinder blocks, crankshaft, inner race or outer race parts made on turning machines, and as well a form for a steering wheel, and also a wheel hub also made on a turning machine. Now, these are already some examples. I have some more. And in case of the engine components, crankcase again, mold for a gearbox cover or a cylinder head, or impeller rim for turbo loader. Some chassis parts, for example, a mold for alloy rim, or brake disc made from ceramics, or camshaft again. Typical parts from the automotive industry. Some more parts from the powertrain industry, for example, a sliding sleeve for a gearbox, or a tripod housing, or a center console. In the exterior field, a mold for a bumper, very huge form. From the chassis, a steering knuckle, for example, or a ball hub from the powertrain industry. Typical parts made on milling or turning machines. All right. The medical technology, the next I would like to introduce, whereby the technological possibilities are not the limiting factor here. Instead, it is the high demands on the certification requirements and standardization that determine the process in medical technology. Barcode readers, the measurement and marking of parts as integrated options in the production process will both simplify and accelerate documentation and tracking. Demographic development and rising healthcare expenditure caused by a higher standard of living mean that medical technology experts are certifying extraordinarily high potential for growth. Special requirements are placed on material used in the medical industry. The following properties are often required. Biocompatibility means skin and body compatibility, wear resistance, strength, rigidity, and toughness. Often used materials are titanium, high-strength plastics, stainless steel, aluminum alloys, magnesium alloys, and particularly in the dental field, ceramics, zirconium, or glass ceramic. So I would like to show you another video from this industry. I hope you don't find the video too much as a commercial video, but I think there's a short and good insight into the medical industry.
Innovative processes enhance the quality of our lives. For our customers, we transfer power into first-class efficiency in a small space. At the Medical Excellence Center of DMG Mori, our experts will be involved at an early stage in the development of our customers' products. This is how we design groundbreaking technologies for the efficient production of high-quality parts. We increase productivity and bring progress to daily life. Decades of experience and the will to achieve perfection turn our machine tools into groundbreaking instruments for the production of high-quality components. We develop innovative solutions for demanding materials. The results are true masterpieces, patient-specific solutions on a world-class level. DMG Mori, medical competence.
All right. Some more examples for the medical technology. Here, some implants, like various implants or hip joint bolts, or a knee joint, a bone plate, clavicular, spinal hooks, or bone screws are typical implant parts in the medical industry made on turning and milling machines. Some more examples in the field of prosthesis. For example, a foot prosthesis, a foot core, a lower leg prosthesis, and a leg prosthesis component. Most of them made of titanium or stainless steel or special aluminum or magnesium alloys. Because of the requirements of the special requirements in the medical field. In the dental area, we have some, for example, some dental bridges, dental crowns, or some pontics, dental fillings, dental prostheses, or just dental implants. Mostly made with ceramics, zirconium, or glass ceramics. And not only made only on turning and milling machines, also made on ultrasonic machine or additive manufacturing as well. Also, some instruments are needed in this industry. For example, sterilization container made on a milling machine. That's also an aluminum alloy, a special alloy. Or instruments like scissors, forceps, close clamps, or navigation tools are used in this industry. Okay. The die and mold industry, you see on this slide, already some examples. A water bottle mold, for example, a grill mold, a texturing mold, reflector mold, or a tire shape. Just imagine many objects of the everyday life are made of plastic in today's time. In this case, injection molds are very often used to produce economically large quantities of these items. The requirements for modern tools of high-speed presses are based on the general requirements for machine tools. They are aimed at increasing the efficiency and accuracy of the products as well as increasing the variety of shapes. The economic efficiency is achieved by means of higher stroke frequency, means strokes per minute, greater tool life, and shorter changeover times. The accuracy of stem parts means the production of stem parts within tight tolerances is not only for better and safer functioning of the parts themselves, but also for handling during automatic onward transport or automatic assembly. Consequently, in terms of accuracy, the tolerances of plastic injection molded parts have changed considerably in the recent years. For example, in the year 1999, the tolerances of these parts were plus minus 0.2 millimeters. 10 years later, in 2009, the tolerances were less than this, means plus minus 0.1 millimeter. And presently, the tolerances for these parts are required by plus minus 0.05 millimeters. This has to do with what I told, the handling during automatic onward transport or the automatic assembly. In addition, the areas of application of the stem parts are becoming even larger, the stem parts themselves ever more complex. This development is therefore reflected in the demand for short throughput times and extensive changes in the tool-making phase. Here, some more examples. A toothbrush form, for example, steering wheel, reflector, shoe sole, bicycle helmet, tablet cover or handy cover, water bottle, typical parts in the die and mold industry. So many processes are now highly automated and the plants run unmanned in night and weekend shift, 24/7. Milling and eroding systems are combined in flexible production cells. Robots automatically load the systems with workpieces and tools. Here too, to further introduce this industry, I would like to show a short video and then some sample workpieces.
As a leading tool and mold maker, how do you meet the many requirements from the various industries? How do you manage to combine limitless flexibility and the highest level of precision? In our DMG Mori Die and Mold Excellence Center, we combine the innovative power of the most varied industries with our entire experience of more than 50 years of machine development. Experts are involved early on in projects for our customer. Therefore, DMG Mori is able to offer for die and mold individual production solutions for all requirements with a continuous process chain. With the expertise from more than 20,000 successful customer partnerships around the entire world, we guarantee the process reliability of your production right from the first workpiece. As a full liner, we always have the machine solution perfectly aligned to your requirements. For all materials, workpiece dimensions, processing tasks, and component geometries. Pioneering technologies open up unlimited possibilities. State-of-the-art control technology ensures highly dynamic machining processes. Intelligent automation solutions maximize your productivity. We are your partner for cross-industry excellence, unmatched precision, and unique process security. DMG Mori Die and Mold Excellence Center. Welcome to the future of tool and mold making. Your individual and fully automated production.
For a car, 300 to 350 sheet metal parts are needed. Each part requires a unique tool set consisting of 4 to 9 dies. In total, more than 2,000 dies are needed for manufacturing all sheet metal parts of a car. Here you can see very well the different materials with different requirements. Different materials, for example, mild steel, high strength steel, higher strength steel, ultra high strength steel, hot formed steel, or aluminium. Some parts have a highly safety relevance. That's why they need another material than, for example, chassis part. And this sheet shows impressively the variety of metal parts of a passenger car and their different materials, which are very diverse due to the different requirements. For example, components that are relevant to safety are made of bigger quality materials or higher quality materials, and then other components. Some more examples. Tabulars are made with a tabular form. A tires mold is one segment of a tires mold. Then mold for plastics, mold for bottle cases, press mold for bumper again, or a hip joint mold. All these tools and dies are made on milling machines, mostly sometimes turning machines. And the selection of the right material for the construction of injection molds is defined and influenced by a whole host of framework conditions and factors. The right balance must always be found between product lifecycle, costs, and quality. One of the most important factors is the output quantity over the service life of the injection mold. In the case of a sample mold from which only 100 parts are injected, it can often be sufficient if the mold is made of aluminium. For this purpose, there's a special aluminium alloy with a high strength for mold making. If the tool is designed for an average number of pieces, let's say 100,000 parts, a significantly better quality of the material is necessary. For example, the form frame is made of a tempered tool steel. The mold inserts and slides can be made of a hot working steel. Another factor is the surface of the finished plastic part. Not every steel grade is suitable for a viewing surface. For a high gloss surface, the tool steel should contain chrome. Particularly in the automotive industry, a large number of plastic parts with a grained surface, or let's say a texture, are required in the field of vision. Leather scars are such a possible surface. It is etched or lasered into the mold insert and then forms a leather structure in the plastic part. As a possible steel grade, hot working steel is also suitable here. All right, ladies and gentlemen, the next industry I would like to introduce is the power engineering technology. The power engineering industry includes the manufacture of all components related to generation of energy. For example, components for sun carrier, components for wind turbines, components for hydroelectric power production, components for power generators, or components for oil and gas production. In the following is a short video and some application examples for the power engineering industry.
Whether a million kilometers away or within reach, nature's energy sources offer us untamed power. In order to utilize these almost limitless resources, we need perfect precision, maximum efficiency, and intelligent production technology that quickly and reliably brings modern materials into top form. This is why we are developing pioneering energy systems. On land, on water, and in the air. Highly precise and thermally stable machine tools. Optimally customized to the specific process chain. Equipped with unmatched efficiency, extreme flexibility, as well as decades of experience from a global leading machine tool manufacturer. Optimally customized to the specific process chain. This is how experience and innovation produces new energy for the world of today and for the generation of tomorrow. DMG MORI, Power Engineering Competence.
Typical workpieces in the power engineering industry. You can see on the next slide. For example, turbocharger impellers, gas turbines, connection rods, turbocharger housings, or crankshaft housings, or some drill heads for the oil and gas production. These are typical workpieces in this power engineering industry. All right. Last but not least, I would like to show you next slide. This deals with the general mechanical engineering. In addition to the 5 sectors described above, general mechanical engineering is also to be mentioned. A large number of components for machines and plants for other industry are manufactured here. For example, machine elements, devices, instruments, tools, screws, pens, bolts, or like shown in this slide, a milling tool, the base of the milling tool, in this case a face mill, or a cast iron machine bed is also produced also on a milling machine. A turret of a turning machine is made on turning machines or milling machines, or a waterproof housing for a camera, or for example, a golf putter. All these parts are made in the industry general mechanical engineering. All right. Question to you as an audience. The components of the various industries are subject of certain requirements. Which ones could they be? Do you have any idea? Please use the chat function. So I have a problem now. I can't see all the chat inputs from your side. I have to switch. Yes, sir. So I can't read your inputs. So don't worry, I just leave the session, but I will be back in a few seconds. Okay, I see already. Rigidity, biocompatibility, tolerance, precision. All right. Great. Okay. How to go back? Oh, sorry. Hmm. Oh, sorry. You didn't understand? Do you hear my voice? All right. Hello.
Yes, I hear.
I was interrupted. Sorry for this. Yeah, I was interrupted. Okay, the question was the components of the various industries are subject to certain requirements. Which ones could they be? And some of you gave already a response. Materials, material properties, accuracy, shape and geometry, and surface finish. These are the main requirements to producing components in these industries. Next question to you is, what all is needed for the production? You can also use your microphone. What do you think? What all is needed for the production? Any idea?
Special alloy.
Special alloy, yeah. Okay. Something else?
Plastic.
Plastic. Okay, don't think just about material. Think around the production, generally. Are there any questions from your side to the presented industries, to the example parts? Are there any remarks, questions?
I do have a short question. Can you hear me?
Yes, please, please.
Yes. I was watching a little video that explained that most of the times in the aerospace industry, because some parts are not to be found anymore, reverse engineering is used. Is that true?
Sorry, one more time, please.
No worries. I was reading that in the aerospace industry, because some of the parts were produced way back in the days, that now reverse engineering could be used in order to remake those parts. Is that true? Is that the case?
Yes, that's the case. Yes, it's the case.
And in that case, how would CNC machines come into play into that?
You mean in the aerospace field?
Yes, exactly.
Okay. What kind of CNC machines? Didn't understand the question well.
Yes,
What kind
no
of
worries.
CNC machines? Or?
If, for example, we're talking like turbines or some casing, and
Yeah.
in the case that you can't find like molds for it anymore, you need to reproduce the parts. So how would like CNC machines play in that process?
Okay. Let's say all parts made of steel, for example. Yeah?
Mm-hmm.
Normally they are made from cast iron parts. Yeah. And the further production processes are on CNC machines, because the accuracy of a cast iron part is not enough for this industry. So in this case, huge milling machines or huge turning machines are used for produce several parts in this industry. Is it what you mean? Sorry?
Yes, that makes sense. Thank you. Especially on the accuracy part.
All right. Okay. Some more questions, please?
Hello, sir.
Yes.
Can you hear me? I have a question about the die and mold industry. I don't understand about. I want to know what is the die and what is the difference between die and mold, sir?
Okay. That's a good question. That's the die. Yeah. Die and mold. A die and mold or mold is made from many parts. Yeah. Many parts like slides and stamps. Then the mold. It's a very complex process. A die and a mold is made from a lot of parts. That's the meaning of die and mold. It's a description of the main parts of a injection mold. Unfortunately, I don't have a video how an injection mold works. Yeah? But of course, in the internet, you find many videos of injection molds. And in these videos, you'll see the several processes, the sequences, and the parts, of course. And most of these parts are made on a CNC machine. Yeah. Today's presentation was only a rough overview to the main industries in the mechanical engineering field. Of course, we have a lot of more industries, but the main industries are shown today, but only a rough overview. Yeah.
Yes, sir.
All right. If you have some more questions, you can also use the chat function in the next days. Yes. because I'm in this channel also, I'm going to try to give you a reply. For today, I think it's almost enough. What is a good startup or a start into the program, I guess. The next session is on 18th of February. And the preview of the next session, you see on the last slide here. We will talk about the fundamentals of material science and mechanics. For example, the properties of the materials will be a topic, the overview of materials and auxiliary materials, the fundamentals of alloys. Also, the fundamentals of technical communication will be a topic, and the variety of manufacturing processes. We not only have turning and milling, of course, they are the main processes, manufacturing processes, but of course we have many other processes, right? Drilling, reaming, EDM, whatever. Yeah? Additive manufacturing, all these manufacturing processes we will talk about in the next session. I also want to upload this presentation in our channel afterwards. And I think about to upload already a training manual for CNC programming or CNC basic, let's say. How CNC machines work, coordinate system, for example, reference points in the working area, how to calculate intersection points of contours, how to calculate cutting data, the basics of CNC machining. I have a training manual and I'm going to upload this manual in the file store of this channel. And maybe you can have a look already in this manual before the next sessions start, as a preparation for the next sessions. Is it okay for you?
Yes, that's fine.
All right. I will do it latest on tomorrow to upload these files. Today, I have another meeting afterwards. I don't have the time, sorry. All right.
Fine. Yeah.
Do you have some more questions?
No.
Lecturer, I want to know the CNC machine produce the milling and turning in one machine, or it's the
Yes.
different machine?
Oh no. The processes, milling and turning, come more and more together, because the challenge for our customers, or for all the customers in these industries, are producing workpieces on one machine. They don't want to unclamp a workpiece to set up another machine with a workpiece. It wasted time. The target is always to produce a workpiece on one machine. That's why on turning machines, it's normally today, those days, to have drilling processes, milling processes, and in the other way as well. On milling machines, you can have turning operations. But these machines are special machines. Yeah, this I will show you in one of the next sessions. Yeah? You have for example, on a turning machine, you have the possibility to use driven tools in the turret for milling and turning processes, but also you can have a milling spindle on a turning machine for turning and milling and drilling. And that's the state of the art. Modern machines are able to have more than one machining process on one machine, also grinding, yeah. And that's the requirement the customers have those days. Machining on one or more than one machining process on one machine. And as possible, or if possible, to operate a workpiece from each side of the workpiece. Means for turning parts, for example, not only the first side of the workpiece, also with a subspindle, the reverse side of a workpiece. The target is always to reduce cycle time and to have an economically production, just to save money. That means machine manufacturers like DMG MORI always create new machine types with higher technical level to reduce cycle times. This I show you, I think, in session 3 or 4. Yeah, session 3. Then we talk about machine types. We have different machine types in milling, for example, horizontal machines, vertical machines, 5-axis machines. And that's our topic in session 3. All right, some more questions? All right, then I would say enough for today. I'm looking forward to session 2 on 18th of February.
Okay.
With the topics I've shown before. And maybe you can have a look already in the training manual. I want to download tomorrow. Have a good time. Thank you for your attention. It was a pleasure for me to give you today the start for this program. Take care of you. And see
Thank you.
in 2 weeks, ladies and gentlemen.
Thank you, lecturer. See you
Thank
in
you.
session 1.
Bye-bye.
Goodbye.
Bye-bye.
Goodbye.